Hello everyone, I am Snigdha Kakkad and this is my channel Accelerate AI Careers. Today I've brought an interesting LeetCode question, LeetCode 670 maximum swap. It's a medium level question, but if you try solving it, you will realize that the difficulty level is actually high because the intuition behind this question will yield to either maximum of O of n square time complexity or O of n time complexity but with two passes. Both the solutions are not the optimum solutions. I made the same mistake when I solved this question for the first time, and that's why I'm discussing this question here, because the optimum solution for this question will be of n time complexity with just one pass. Now, why is it so important? So this question has been asked by these companies in their last 3 months of interviews. Meta has asked it 21 times, Amazon, Google, Talks, Microsoft. These companies have asked this question in their last few months of interviews. Now let's look at what does this question say. So you have been given an integer num and you can swap at most only 2 digits in that number such that you get the maximum valued number out of it. And you have to eventually return that maximum valued number, whatever you get after making that one swap. So you can swap only 2 digits. Now example 1, you have been given num 2736 and you have to swap only 2 digits. So either you can swap 2 or 7, or you can swap 7 or 3, or you can swap 3 or 6. So just intuitively, you would think that I have to bring the highest number to the most significant place. And then I would say that the highest number or the max number is 7, and I have to bring it at this place where the 2 is. And hence I'm swapping 2 and 7. And my final answer is 7236, which is the maximum number possible. But just suppose if in place of 2 you would have had 9. Then your number would have been 9736. In such a scenario, you would have found the maximum number, which is 9 itself, and you would say that, okay, then swap 9 with 9 itself, and you already have the max number 9736. But there is a swap possible there. There is a swap possible there between 3 and 6, even though 6 is not the most significant or the highest number, but 6 is greater than 3. So the highest number possible out of those 4 digits would be 9763. So that brings another intuition that you have to obtain a monotonically decreasing number. If you have a monotonically decreasing number, then you cannot bring any swap because you have the highest possible number already. But if it is not monotonically decreasing, then you don't just need to find the highest or maximum number. You also need to align them in a monotonically decreasing order, or at least try to do that so that you obtain the maximum possible number. Now let's look at example 2. You have been given the number 9973. As you can see, it's already in a decreasing order and there is no possible swap you would make that will increase this number. Hence, no swap is your answer and output would still be 9973. So this is the basic question. Now let's take a few examples and understand what we can do, how we can solve this question. So say suppose my first example which I have is 5736. Instead of 2, I'm taking 5736. This is the example which I have initially. So if I am a novice and I don't know any coding techniques and I want to solve this question, how would I go about it? I would first take this number 5 and find if there is any other number to the right of it which is greater than that number, and I can make that swap. So I find 7 which is greater than 5 and I can make that swap and I'll get 7536. So that would be my number. But say suppose instead of 7 if you have 4 and instead of 6 if you have 3. So 5433. In such a scenario, I will check if there is any number to the right of 5 which is greater than 5 to make the swap. I will not find any because all the numbers are less than 5. So I will search for any numbers to the right of 4, this next significant number, and any number to the right of 4 which are greater than 4, and I can make a swap. I will again not find any. But suppose if instead of this 3 I have 6. So now I will find 6 which is greater than 4 and I can make that swap. So essentially you will be taking 2 nested loops and you will be going through every significant number starting from the most left one. You start with this 5, then go to the 4, then go to the 3, and then go to the 6. And for each number you would check, is there any number to the right of it which is greater than that number so that you can make a swap. And that's how you will run till the end of the number and check. And then you will move towards the next significant number, check for it. Next significant number, check for it. As soon as you find a number greater than in that number in the right direction, that is the time you would make the swap and return the result, because you have to finish only one swap. So this will be your brute force approach. And in this brute force approach, the time complexity would be O of n square, since you are doing a lot of repeated work. Every time you are picking a most significant number, you're checking to its right if there is something greater than that. So essentially, you're finding that max number to the right of it again and again, again and again. So your time complexity would be O of n square. Now you would be wondering, is there a way to remove this repeatable action of finding the max? Can I do better? So another approach which I can do to reduce the time complexity from O(n) square to O(n) is, instead of again and again picking a number and going in the nested loop and checking for the number in the right direction, I can convert this number to a string and then that string to a list, to an array, so that I can have each individual number, each individual digit at a particular index. So instead of 5, 4, 3, 6 being a number, I will have an array of 5, 4, 3, and 6. And if I have this array, I can also have an array where I'm maintaining a max number. And I will not start from left to right, I will start from right to left. So if I start from right to left, for this 6, which is at index 0, I will check if there is any number which is greater than that number to its right. So since it is at 0th place, there is nothing. So I will maintain that max as 6. So that array I will keep on updating for max. Now I will check between this 3 and 6, is there any max which is greater than this 3? Of course there is, which is 6. Now I come to the next index, which is 4, and this value 4, is there any max value to the right of it which is greater than 4? So I'll compare with the last max, which is 6, and yes, 6 is greater than 4. So the max here would also be 6. Now I'll come to the final or most significant integer 5. Is there any value to the right of it which is greater than 5? And yes, there is, which is 6. So this would be my max array. So this was the first pass, and in the first pass I obtained my max array. After obtaining my max array, I will traverse from my most significant position, that is here from 5, and see is the max for 5 or greater than 5. If it is greater than 5, then that is the swap I need to make. So that's your entire question. I'll find 6 here, and which is greater than 5, and I'll make a swap between 5 and 6 here. And instead of storing max 6 here, I can also store the indices here, or I can do another pass and check for where 6 is, and I can find it and I can do the swap here. So this is the possible solution where the time complexity would be O of n, and there would be 2 passes needed. One to find the max, and second to actually perform the swap with the max. So this is your solution. But can we still do better? Can we do this question without maintaining an array just to trace the max? So answer is yes, you can do that, but you would need 4 variables there then. You would need to find max digit and keep on updating it when you are traversing. You would also need max index, which you would keep on updating as and when you are traversing, and so that you have an index which you need to swap. And then you will have 2 indices, which is swap I and swap j, for the 2 places where you will be switching. So for example, 5, 4, 3, 6, your max is 6. So max digit becomes 6. Your max I will become index 3, because it's 0, 1, 2, 3. Index 3 would be your max here. And then your swap I right now will also become 3. Now you'll keep on moving and keep on updating these. So you come to the index 2. Now in index 2, your digit is 3, which is not greater than max digit, which is 6. So it will not take its place. But your swap j will have this index 2, because you can swap index 2 with index 3, right? Because 3 is less than 6. Now you come to index 1, where the value is 4. Now this is more significant than 3. So you can update your swap j with index 1, because if you replace 4 with 6, you'll get a larger number rather than replacing 3 with 6. That's why I'm moving backwards. I'm going from index 3 to index 0, from least significant place to most significant place. And I'll keep on updating my swap j, swap I. I'll keep on updating my max I and my max digit, so that I have a track where my max place is and which 2 indices values am I switching or am I swapping. So this is the notion behind the most optimum solution possible for this question. And what I'm actually doing here is I'm basically using 4 variables to track everything rather than an array to track max. And this will help me to solve this question in O time complexity with just a single pass. So I hope you understand this question. If not, take this example and try solving it yourself. Keep on updating the values starting from backwards index equal to 3, that is value 6, and keep on updating and see if you make the right swap and get the maximum number possible. Now, since I have explained the intuition behind this question, I would like to explain the code also. So let's code it. You can code it alongside me. First of all, I will take my num and I will convert it to string because I have it in integer form. As you can see, it's given as integer here. So I'll first convert it to string, then I'll convert it to a list. And I'll reallocate this value or reassign this value to num variable. So now once my num value has been converted to a list, I will initialize my all 4 variables, which is max digit. Max digit I will initialize as 0 and max I will initialize as -1. And then swap I and swap j I will initialize as -1 each. And I'll keep on updating these values as and when I move through the entire number list or num list in reversed order. For I in reversed, range, length of num. That's how we do it in Python. That's how we traverse in Python in reversed order. And then first I'll keep on updating max and then I'll keep on updating my swap. So there would be 2 places where I update. So first to update max, I will check if my current num, which is num I, is greater than my current max digit. If it is greater, then I have to update my max digit and reassign it to num I. And I also have to update my max I to I because I have obtained a new max, right? Now for swap, I will check if my num I is less than my max digit. Because to make a swap, you will search for max and then swap it with max. So if my current number is less than my max digit, I will update my swap I and my swap j. So I'm making a swap between ith index and I'm making the swap between max I index. So the one which has max digit and the one which is current number, which is less than max digit. So I'm making swap between those 2 indices. So I'll keep on updating my swap I and swap j accordingly. And this whole process happens only in one traversal, only in one for loop. And hence the time complexity is O(n). Now only one last thing is remaining where I will make the actual swap. So num swap I, the first index, and num swap j, these would be equal to num swap j, where I'm making the actual swap, num swap I. I hope you understand how we are swapping, and then I have to return the answer. And what will be my answer? My answer should be in an integer form since I obtained the number in an integer form, but I had converted into a list. So to convert a list back to a string, I will have to use an empty string and do a join, and that join will join the num. And that's how I obtain the integer form of my result and I return. Now this is my entire code. So first I converted my number to string and then I broke it down into a list of strings and then I reallocated it to num, my num variable. Then I initialized my 4 variables max digit, max I, swap I and swap j. Once I have initialized them to the base max digit as 0 and max I, swap j, both 3 indices as -1. I traverse through the loop in reversed order. That's how we do in Python. And then I always compare my current index number with the current max digit. If the number is greater than max digit, I keep on updating the max digit and max I. And on the contrary, I'll check my current number and compare it with max digit. If it is less than max digit, I'll keep on updating my swap indices. And then I actually make the swap. And once I've made the swap, I have to return the result. And I return the result actually by converting it into a string first and then to an integer first. So this is the entire code. Let's run it. If I have not made any errors, it is accepted. Let's submit. So as you can see, our solution is doing really well here. It's one of the most optimum solutions. It beats 100% answers available here on LeetCode. So that's the entire code. If you have a better approach to solve this question, share it in the comments here. Also, let me know how did you like my problem solving for this question. If you have any other question which you want me to prioritize or solve first, mention in the comments. I would like to take it further. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.